Water dispenser playing an important role in university campus. It has been installed in many areas such as academic buildings and lecturers' office. But now we have faced some problem from water dispenser, which is the water flow of the water dispenser became slowly and suddenly it doesn't come out from the water dispenser. So it will lead to negative impact to the student and staff. So we decide to use three tools to provide a solution about how to fix the problem of the water dispenser.
For this section, we're focusing on the current condition of water dispensers at Unimas. To access to a clean water and reliable drinking water is a basic necessity in a university environment at Unimas. However, based on our observations, the reliability of these dispensers remain a major concern. Many units are frequently out of service due to mechanical problems and the water tanks, clogged filters, or delay maintenance. Next, these slides show students' feedback collected through our survey. From the charts, we can see that the most students rated the water dispenser service as only moderate in terms of sufficiency and quality, while the service is generally useful and it does not fully meet student expectation. Next, based on student responses, this includes no water coming out of the dispenser and a noticeable chlorine test in the water, inconsistent hot and cold temperature settings, unhygienic conditions, and insufficient number of water dispensers in faculty buildings and residential college.
That sounds good. So I'll be extending on the ideality all the way to the physical conviction. So moving on to the ideality, the ideal final result for the water dispensers is that the students can receive clean, safe, and consistent drinking water at any location on campus without any noticeable maintenance effort, extra cost, or any system complexity. The ideal solution will achieve at least water quality that is always safe and consistent alongside water sources that are available everywhere around campus. Moving on for the cause and effect analysis. For the root problem will be inconsistent water quality and accessibility to water dispenser alongside unreliable access to drinking water. So for the function analysis will be system components will be water source filter unit, internal pipes, dispenser outlet, sensors, maintenance staff, and students. So moving on for the function-oriented search. So the target function will be we should deliver clean, safe drinking water consistently and everywhere across campus. For the S-curve, the current stage in which the water dispenser will be at should be at around late growth or early saturation stage because technology already exists and performance improvements are slowing. Problems now stem from the management and not from anything else, not from technology. So moving on to trimming. Excessive. So one of the components that needed to be trimmed is the excessive manual inspection, and the result should be a simpler, more efficient system with lower failure rates. So moving on to the engineering contribution is increasing filtration strength improves quality, but increasing filtration strength also reduces flow and consistency. So for the final thing, physical contribution, filter must be dense to clean water. Filter must also be dense to allow for smooth water flow. So both of these points contradict each other. That's all for me. Thank you.
All right. To solve the low water flow and maintenance delays at Unimas, we've applied four TRIS principles to optimize our dispenser system. Firstly, using the 10th principle, which is preliminary actions, we've scheduled automatic refills during non peak hours. We can combine this with the 24th principle, which is intermediary, which basically means adding a secondary storage tank to act as a buffer. This ensures the system is always preloaded to handle high demands without the flow of water slowing down. Next, we've applied the second principle, which is taking out or trimming to remove the slow manual inspections, replacing them with an automated sensors. This works with the 23rd principle, feedback, using digital displays to provide real-time alerts on the filter health and the water levels. By eliminating manual errors and ensuring a constant supply, we've created a more reliable system. This reduces wait times and encourages the use of refillable bottles, directly supporting the sustainability across the Unimas campus.
Next, we will be looking into evaluation and discussion. In this section, we will be covering three perspectives, which is cost-wise, feasibility, and also the sustainability. Looking into cost-wise, the solution proposed focus more on improvising the existing water dispensers provided by Unimas around the campus instead of a full replacement. And initially, this does need investment. However, operational costs are able to be reduced through automated monitoring and also preventive maintenance. Other than that, feasibility-wise, the proposed system is indeed feasible as it uses today's reliable and available technologies. And implementation is met by stages from highly used area to less, ensuring little to no disruptions of the campus life activities. Other than that, when we look into sustainability, this proposed system does promote usage of refillable bottles and reduces single-use waste, which is an implementation of elements of environmental friendliness. It also promotes prevention of water wastage, which is covered by the real-time monitoring feature. Lastly, feature of distributed purification, which improves the water quality. So overall, this proposed system of solution does impact university life positively, and it is indeed a cost-effective, feasible, and sustainable improvement to the existing water dispenser system, which at the same time uplift user experience and also operational efficiency throughout the campus. To conclude, this whole study is the implementation of three tools under the analyzed problem students and campus community has faced upon the current water dispenser service in terms of water quality, availability, and also maintenance efficiency. But despite all of the following advantages that has been evaluated previously, there is still further improvements that need to be done. So some of the suggested further improvements is including quantitative performance evaluation using measurable indicators such as water quality consistency, maintenance response times, and also cost savings. Other than that, user experience surveys is also relevant for feedbacks onto the new implementation. And overall, the proposed solution is indeed a practical, fundamental approach in providing improvised campus drinking water system, at the same time supports our long-term sustainability goal, including smartly operation facilities in the campus. Thank you.